We want to solve the following system of equations by the substitution method. So if you remember correctly, the substitution method means that we have to solve one of our equations for x or for y and then plug it into the other equation. So what you want to look for is you want to see if there's anything that I see of x's and y's that already has a coefficient of 1. So when I'm looking at the second equation, I notice the coefficient of the y is 1. So I'm going to take the second equation, and now I want to solve that for y. So to get y all by itself, I'm going to subtract 2x from both sides. So I get y equals 1 minus 2x. Okay, so I've already used the second equation. So I always put a little x next to it to know that I cannot reuse that equation. So I'm going to take what I just got for y, and I'm going to plug that into the first equation. So first I'm going to rewrite it. And now everywhere there's a y, I'm going to plug in what I just got, 1 minus 2x. So now what do I need to do? I need to distribute. So I'm going to distribute the 2 throughout. I need to combine like terms, so I get minus x plus 2 equals 4. I need to get x all by itself, so I'm going to subtract 2. I get minus x equals 4. But I don't have x all by itself, so I need to divide by -1. So I get x equals -4. Okay, so I know what x is. Now, what I need to do is I need to go back and I need to find out, oh no, I don't. There's a typo there. We want to solve this system of equations by substitution. Now, if you recall, substitution means you have to substitute one value, x or y, into the other equation. So how am I going to do that? Well, the best rule of thumb that I can give you is you want to find if there is an x or a y term in either equation that has a coefficient of 1. So when I look at the second one, I notice that the y has a coefficient of 1. So I'm going to copy down that equation, and I'm going to solve for y. So I'm going to subtract 2x from both sides, and that's going to give me y equals 1 minus 2x. Now I've already used that equation, so as a mental reminder for me, I physically put an x next to it in the system of equations. So now I know I have to use the other equation. So how am I going to do that? Well, I just solved for y, so first I'm going to rewrite that equation. And now everywhere there's a y, I'm going to plug in what I just found. So 2 times 1 minus 2x. And then I need to use the distributive property, so I'm going to distribute the 2 throughout. I'm going to combine like terms. I'm going to subtract 2 because I need to isolate my x, so I get minus x equals 2. But I don't need minus x, I need x, so I'm going to divide by -1, and so x is going to equal to -2. Okay, so I've got that. Now, what am I going to do with that? Well, we use substitution. So I've already substituted that y into this equation, so y is already solved. So now what I'm going to do is I'm going to take the value that I just obtained, and I'm going to plug it back into what I'd already said y was. So I'm going to get y equals 1 minus 2 times -2, so 1 plus 4, so y is going to equal to 5. Now, are you 100% sure that that's correct? You always have to say, no, I'm not. So how do you make sure that's correct? Well, you're going to have to plug it back into the given and see if it's a true statement. So I'm going to set that up, and then when you come back, you're going to see the answer. So on the right-hand side, what I've done is I've actually checked those values in each one of my equations, and sure enough, they each made a true statement, so these are both solutions of the two equations.